Hi everyone, I'm Sri Surya. I'm representing Linux today. Um, I've completed my graduation in 2024 last year, and so I just completed my graduation in 2024, and I started exploring Zephyr in the last year. And my first contribution to Zephyr was started with writing a RTC driver for AMBIC-based SoC, just AM1805, and then I've started exploring Zephyr more on SoC and board porting level. So this is going to be a very quick talk. As this is my first open source talk, we'll try to be little not technical, but will not bore you, but we'll try to give some good insights. Yeah. So speaking about my title, The Whisper to Storm, the evolution of Zephyr RTOS. So like everyone just heard, like definitely my like last 5 years, as Zephyr has become the factory de facto. For example, all the vendors are trying to support Zephyr. Main reason for the support for Zephyr is the community driven. Zephyr as one of the biggest open source project under Linux Foundation right now, and it has been the talk of the town for the last considerably 5 years, and I'm not sure how many people have worked in Zephyr here, but I definitely know like you are here because some reason Zephyr has like made you to sit here. I'm happy about that. So just about the slide, I would like to tell like lightweight at heart, powerful in purpose. The reason for the lightweight is about the core, which is the kernel. Kernel being lightweight, we serve multiple purpose for different vendors, and not just in words. We can see that there are like around 750 boards across 40 vendors support Zephyr, and that's the main reason that we are saying that Zephyr has become factory de facto. So not just on not just on development boards, we do have our real-time products mentioned in the Zephyr page. So these are some of the real-time products that actually run Zephyr. For example, about the scooter and the OBD dongle, about the animal tracker, the wristband, the hearing aid. There are some examples of Zephyr in real time. So I would like to thank the community. Like without the support, it's not possible to reach a great milestone of 1 lakh commits, and it's like around 1,15,000 commits, and we reached this milestone in the last 2024, end of 2024. So just talking about this, I would like to just let you know a quick thing about the release cycle. So for every for example, for every LTS and a regular release, we have RC. RC will be released for like around 1, 2, 3, or for version 3 we had like around 5 RCs releases, and for the stabilization we have the RC releases, and for every around 2.5 years we have an LTS release, and a regular release will happen every 6 months, and we have a naming convention for versions like major. The first one represents the major number, and the next is a minor number, and the third one will represent the patch level. So this so every 2.5 years this LTS release will be considered for a long-term support, and that will be supported. That's about the LTS. So let's go to the main topic that I'm going to address is about the code changes. So this is just the Zephyr directory. So this was how it was like previously. I mean the V1, which is like around 22 MB. It's around 22 MB, and now it has changed like around 385 MBs. So this codes this covers everything, including the architecture support addition, and board support addition, changes in the kernel, and some modifications for the improvement of Zephyr as a real-time operating system. So this is a quick view. About the trajectory. So when initially this was launched as open source in 2016. Previously, the work for Zephyr started in 2014 in Intel. So in the first public release in 2016, we have support for x86 and ARM, and we had something called nano kernel and microkernel. Like right now we don't have, and it is got. Right now it is like merged into a single kernel. I mean, there is no dual kernel. I mean, I just went a little bit about it. I'm not went deep inside this, but I came to know that nano kernel will do the major major scheduling with cooperating and cooperative scheduling and primitive. And this microkernel will combine together and give the APIs to the application and try to consume the kernel APIs for the application. So so that is the part in V1. Sorry about that. That is the part in V1. And in V2, we have support for native POSIX. Like in previous talk, Vaishnav mentioned, like we can natively run the Linux ELFs in Zephyr, and the support for that. And we have RISC-V and extends architecture support. And previously, we have 32-bit support for x86, and 64-bit was added there. Then we have support for Bluetooth, and the device tree was also added. Actually, the major release of one of the major release in Zephyr is V2. Made a lot of changes in device tree and the introduction of West. A lot of changes happened in V2. And in V3, again, we add a support for ARM64 and Spark MIPS architecture and support for symmetric multiprocessing. And modem support was added and pin control. So finally, in V4, just to mention, like I was just mentioned, Rust, and we have further. I mean, all these releases include multiple number of board supports, multiple number of architectural improvements, multiple number of subsystems added, multiple number of drivers implemented. So, like everyone who is aware of, Zephyr and are doing any just an application building must came across these two things. Surely about build system. So previous build systems, like we were using Make, then the transition to CMake happened, then Ninja, then West combines everything to give an interface, to give a build system, not just for building, for also for flashing and taking care of other multiple things. So we say Zephyr is modular and flexible. The main reason for modular is before the introduction of West, HAL was part of Zephyr, and previously HAL used to be in Zephyr, and all the changes made in the HAL will impact the Zephyr also. The Zephyr tree also will be impacted for HAL. So after the release of West will take care of the board, and West will take care of which board you are compiling. You just need to mention West-B build and the board of the name. That's enough, and West will take care of everything. So in the previous versions, Zephyr is not taking care of the flashing thing also. Like before West was coming, flashing is done by the individual user itself. For example, you build a file, and it's who is building the file. That is his responsibility to flash it. Zephyr is not giving any support for flashing in the old releases, but after West comes, everything come inside, and we have different flash invoking based on the boards, like NRF JProg or specific for STM boards. We have different flashing utilities, JFlash, everything. It is invoked, and the responsibility is taken care by West itself. So that is one of the main thing. And I would like to tell about a device tree, as previously Vaishnav mentioned. Like we have device tree here, and it is also part of V2, but it is build time configurable, because we don't have we are not having kernel looking up the compatibility at the runtime and loading the drivers at that point. So this happens in the build time. So previously when device tree was not part of Zephyr, how they used to build is they have kconfig, and they have specific board level pin configuration file which contains all the informations about the specific board. Will be in form of like .c and .h that will be combined, and then like instead of device tree, that mechanism was used to know the pin configurations of your board. So thank you. And like previously mentioned, like we have, I mean, a lot of improvements need to be done. And like whatever Kasim told, like we should stand as a open source community. And the only reason Zephyr has a hope and still doing best is that being in nature of open source, and everyone can contribute to it. Everyone is adaptable for the change, for the best things, and we will unite together and create a good real-time operating system. Thank you. Yeah. So, is there any questions? Yeah. So, which one? This V4. So actually V4 we have some informations regarding to addition of secure subsystem and addition of stepper motors are there, but I don't think that is I mean worth mentioning that here. That's the reason I was just adding support over there. Yeah. I'm not sure. It is the initial version about it. I'm not sure about the version number. Yeah, like both BLE and Bluetooth was supported in V2. Yeah. Yes. At that time, I haven't explored much on that. Yeah. Yeah. Okay. Okay. Thank you. Thank you, everyone. Thank you.